So now let's look at problem number 2. If I want to invert this matrix, I want to decide whether it's always equivalent to this matrix. You know, it almost again looks like a Gauss transform, except there's a delta here instead of a 1. So let me see. I think it's always going to be true, but let me see if I can prove it. So if I look at the matrix 1, negative alpha, 0, 0, delta, 0, 0, negative beta, 1, I'm going to remember problem number 1, and I'm going to see if I can multiply it or break it into pieces where it's a diagonal times maybe a Gauss transform. I remember, again, if I multiply by a diagonal on the left, it actually just changes or scales the rows, and it seems to me that I would like this to be a 1 instead of a delta. So what I can do is I can break this into a product of a diagonal 1, delta, 1, times the matrix 1, negative alpha, 0, 0, 1, 0, 0, negative beta, 1. And the reason that I did that is because I noticed that this row had zeros everywhere except that one entry, so I could actually break it into a diagonal element that I don't want to change any of the other rows. I just want to change that, make it a 1, so I can write it as this diagonal times this matrix, and it worked. So if I want to find the inverse of this, it's the inverse of this product, which means that it's the inverse of 1, negative alpha, 0, 0, 1, 0, 0, negative beta, 1, times the inverse of 1, 0, 0, 0, delta, 0, 0, 0, 1. Because the inverse of a product, we have to switch the order and take the inverse of each of the matrices. So, what is the inverse of this matrix? Well, if I look at it, notice it is a Gauss transform. And so the inverse is the matrix 1, positive alpha, 0, 0, 1, 0, 0, positive beta, 1. Because I know the special form for the inverse of a Gauss transform. And I also know the inverse of a diagonal. It's going to be 1, 0, 0, 0, 1 over delta, 0, 0, 0, 1, because it's going to be a diagonal element with all of the values on the diagonal will be the multiplicative reciprocal of the original diagonal elements. Now, if I'm multiplying a matrix on the right by a diagonal, it actually scales the columns by that diagonal element. And so, or by those diagonal elements, the result is the matrix with first column 1, 0, 0, second column alpha over delta, 1 over delta, beta over delta, and last column 0, 0, 1. Now, what was I trying to prove? Well, I thought that this works, and it does. So it's always the case.